Alright, so this video we're going to take a look at DeMoivre's theorem, powers, and roots. Alright, so if you haven't watched the video right before this one in the playlist, you might want to watch it first, because we got to do it, because a lot of the stuff we do in this video was taught in the last video. And if you're not in the playlist, then what you want to do is search my channel for trigonometric form of complex numbers. That would be the name of that video. All right, so let's look at this. So we've got DeMoivre's theorem. It says if z is equal to r times cosine theta plus I sine theta is a complex number and n is any positive integer, then z to the n is equal to r to the n times cosine of n theta plus I sine n theta. All right, so the complex numbers in trigonometric form, you can see that right here. All right, you see that right there. And then if we raise this complex number to a power, to, you know, whatever power, then this is how we evaluate it. All right. So basically all it is raising r to this number and then multiplying this number to theta. All right, so we've got negative square root of 3 plus I, all that raised to the 8th. Now think about this. If you tried to multiply this out, you would have eight of these. You would have to multiply the first two, and then whatever you got there, multiply it times to the third factor, and then whatever you got there, multiply it to the fourth, and so on. So you can see that would take quite a bit of work. But what we can do is we can convert this to trigonometric form, and that's why I said at the beginning of the video, go watch that other video, because we go over how to convert that to trigonometric form. Okay, I'll explain it as we work it in this problem, but keep in mind this video assumes you know how to convert to trigonometric form. But I will go over it, but not as slow as I did in the previous video. All right, so we need to find r. So remember, r is a squared plus b squared. So a, well, the square root of a squared plus b squared. So a is negative square root of 3, and b is 1. And so this is going to be 3. Negative square root of 3 squared is 3, plus 1 is 4. Square root of 4 is 2. All right, so that's r. Now we got to find theta. So I get tangent theta is equal to b over a. Well, b is 1. A is negative square root of 3. If I rationalize denominator, I get negative square root of 3 over 3. All right, so we got to find theta. Well, notice we get tangent theta is equal to a negative number, and once again I went over this a little better in the previous video. Well, we gotta find the reference angle, don't we? We gotta plot this thing. So a is negative square root of 3, so I move to the left. B is 1, so I move up. And like I said in the last video, I'm not really worried about the exact location of the point. I'm more concerned about what quadrant it's in, and we can see it's in the second quadrant. And so this would be my reference angle, that theta prime there. So remember, to find your reference angle, you set it equal to positive square root of 3 over 3, because the sine, cosine, or tangent of a angle in the first quadrant, or the sine, cosine, or tangent of a reference angle, is always positive, because your reference angle is a first quadrant angle. And so here I would get my reference angle to be 30 degrees. So this is 30 degrees. And so now I get theta is equal to 180 minus 30. So theta is equal to 150 degrees. All right. So what I'm going to do now is I'm going to write this. This is my problem. Negative square root of 3 plus I raised to the 8th. is equal to, all right, so that's equal to r, which is 2, times cosine 150 plus I sine 150. And remember, this is raised to the 8th power, okay? So you see this part inside the parentheses here, this negative square root of 3 plus I? This is that complex number in trigonometric form, okay? So I'm just raising it to the 8th power. So all we're going to do now is use DeMoivre's theorem. So that's r to the 8th, which would be 2 to the 8th, and then cosine of 8 times 150 plus I sine of 8 times 150. N is 8, theta is 150. We did all that down here. And so this would be 2 to the 8th times cosine of 8 times 150 plus I sine of 8 times 150. And let's see, 2 to the 8th is 256 times cosine, and let's see, 8 times 150 is 1200 plus I sine of 1200. All right. All right, so this is going to be 256 times, all right, so now we've got to find the sine and cosine of 1200 degrees. So remember how to do this. 1200, well, we want to get that angle back between 0 and 360, so we're going to use the fact of coterminal angles. Remember coterminal angles? They have the same terminal side, just different amounts of rotation. So let's see if we can figure out where this is. So I'm going to keep subtracting 360 until I get between 0 and 360. So I got 1200 minus 360 is 840. So I need to subtract 360 again. That's 480. So I need to subtract 360 again. That's 120. So 120 is right here. All right. Now, to evaluate this, I need to know what the reference angle is. So 180 minus 120 is 60 degrees. That's my reference angle, 60 degrees. So we've got the sine, I'm sorry, not the sine, but the cosine of 60 degrees is what? 1/2, right? So the cosine of 1200, that we're going to get the cosine of 1200, but first, cosine of 60 is 1/2. What quadrant am I in? Second. Cosine is negative in the second quadrant. So the cosine of 1200 is negative 1/2. All right. You should already know how to do this. This was done back earlier in the trig course. All right. Plus, and then the sine of 60, that's what? Square root of 3 over 2 times I. Well, also, okay, so the sine of 60 is square root of 3 over 2. I'm in the second quadrant. Sine is positive, so it's positive. And so the sine of 1200 is square root of 3 over 2. And this equals, now what do I do? I distribute the 256. And so that leaves me with negative 128 plus 128 I square root of 3. And there's your answer. And, you know, and look, if you took this right here and you did negative square root of 3 plus I times negative square root of 3 plus I, negative square root of 3 plus I, if you had 8 of these factors and you multiplied it all out, this is what you would get. It's just easier when that complex number is in trigonometric form. Okay, that's the whole point of this. Okay, write it in trigonometric form makes it much easier. And you might be thinking, well, that's not so bad multiplying 8 of them out. Well, it's more work than this. But what if your teacher said, okay, you know what? Instead of raise to the 8th, I'm going to raise it to the 20th power. You're not going to multiply 20 of them out. All right? I mean, you could, but you probably wouldn't finish your test if you did. Okay, so make sure you know how to convert all this from the a+bi form to the trigonometric form. Make sure you know how to do that. All right, so that's raising a complex number to a power. That's DeMoivre's theorem. All right. And remember, in order to use it, it has to be in trigonometric form. Your complex number has to be in trigonometric form. If it's not, you have to convert it to trigonometric form like we did right here. Okay. All right, so let's look at this. We've got a definition, nth root of a complex number. The complex number w equals a+bi is an nth root of the complex number z if z is equal to a+bi to the n. Okay, that's just kind of like saying 2 is a cube root of 8, but because 2 cubed is equal to 8. That's what that's saying, something like that. And then we have the nth root theorem. So nth roots of a complex number. For any positive integer n, the complex number z equals r cosine theta plus I sine theta has exactly n, that should be distinct, nth roots given by the expression r to the 1 over n, or the nth root of r. Remember, r to the 1 over n, that's the same thing as the nth root of r. So the nth root of r times cosine of theta plus 2 pi k over n plus I sine of theta plus 2 pi k over n for k equals 0, 1, 2, all the way to n minus 1. Now, you see this where it says theta plus the 2 pi k right here? You see that? That's if you're in radians. If you're in degrees, it's going to be 360 k. All right. So this inside part would be theta plus 360 k over n if you were in degrees instead of 2 pi, 360. All right. So here they want us to find all fourth roots of the complex number. All right, so let's find all fourth roots of the complex number. So the first thing we have to do is we've got to convert this to trigonometric form, because notice in the theorem, what does it say? There's your complex number. It's in trigonometric form, so we've got to convert it to trigonometric form. So let's do that. All right, so first thing, I've got r is equal to the square root of negative 8 squared plus 8 square root of 3 squared. And that ends up being 16. And you can plug it into your calculator to check. Just trust me on this one. All right. Now, we need to know what theta is. All right. So I've got tangent theta is equal to 8 square root of 3 over negative 8, which is negative square root of 3. All right. There's tangent theta. Tangent theta b over a. That's what we use to find theta. And if you watch the video right before this one, then I'm stating there that you can use sine theta or cosine theta to find theta. I just like to use tangent theta. All right. So once again, tangent theta is equal to a negative number. I need to go ahead and plot this. Let's see. Remember how to plot it. A, B. A is negative, B is positive. I'm in the second quadrant. There's theta. So I need my reference angle. So remember to find your reference angle. We set it equal to positive square root of 3. So my reference angle, well, that's what? That's 60 degrees. Let's just do this one in degrees. Let's do it in degrees. All right, so this is 60, and so I get theta is equal to 180 minus 60, so theta is 120 degrees. And I want to find all fourth roots. Let's go ahead and write our complex number down. So the complex number is r, right, times cosine theta plus I sine theta. All right. So there's our complex number, and we want to find all fourth roots. All fourth roots. All right. So find all fourth roots. So we know n equals 4, because what does it say up here? It says has exactly n distinct nth roots. We're looking for fourth roots, nth roots, fourth roots. N is 4. All right. And then we have for k equals 0, 1, 2, 3. All right. But how did you get that? Okay. Well, let's see how we got for k equals 0, 1, 2, 3. Well, what does it say up here? K is equal to 0, 1, 2, all the way to n minus 1. So all the way to 4 minus 1, which equals 3. So k is 0, 1, 2, 3. That's how you get the k. All right. So let's look at this, and let's go ahead and write down theta is 120. All right. Theta is 120. R is 16. All right. So what are the fourth roots of this? Okay. What is it? What is it? All right. So for k equals 0, that's the first one. See, we got to do it for k equals 0, k equals 1, k equals 2, and k equals 3. Then we have, now let's hang on a minute. Let's do this. So we know we've got the fourth root of r, which is 16 to the 1/4, which equals 2. Now, why did I do that? Well, that's going to be the number in front every time. R to the 1 over n, or the nth root of r. All right. And so we decided r is equal to 16. So the fourth root of r, which is the fourth root of 16, is 2. Okay, so we know we're going to have 2. This is going to be 2 in front every time. And then we'll just plug in theta and k and n for this. All right. So for k equal 0, that's going to be 2, that's what we're doing right here, the fourth root of 16, times, and that's going to be cosine, all right, cosine of theta, which is 120, plus 360 times 0 over n, plus sine of 120 plus 360 times 0 over n. That's when k is 0. All right, now let's look at this. Remember your formula. Let's write it down. It's r to the 1 over n times cosine theta plus 2 pi k, but we're going to do it in degrees, so it's 360k over n plus I sine of theta plus 360k over n. So look, all I've done, I've plugged in theta, I plugged in n, and I'm plugging in the k value. You see that? All right, and so this is going to give me, let's change the colors back. So this is going to give me 2 times cosine. So that's 120 plus 0 is 120. 120 divided by 4 is 30. plus I sine 30. All right. Now, I don't know, I don't know about the book that you're using, but the book I'm using to do all this stuff, it wants you to put your answer back in the a+bi form. So let's go ahead and do that. So this is going to be 2 times. So, and once again, going from trigonometric form to the a+bi form, that was done in the last video. Okay, I did that in the last video. So remember, cosine of 30, that's just square root of 3 over 2, plus sine of 30, 1/2 I, and so that's square root of 3 plus I. And so there's your solution for k equal 0. All right, so there's the one for k equals 0. Now, let me explain a little more. Let me explain some more stuff. Now, you understand that this right here is, this is written out. If you watch the first video, you'll remember that if you have cosine theta plus I sine theta, okay, you got your complex number. If you watch the first video, the video right before this one, you should remember this. Remember, we can write this in abbreviated form. Instead of writing all this out, this part right here, we abbreviate with this. And that's what I'm going to do from here on out. I'm going to, instead of writing cosine this plus I sine this, I'm just going to write CIS and then this. That's an abbreviated form. Do it on your test too. I mean, if you're in my class, you can do that. That's fine. Okay, just make sure you check with your teacher and make sure they don't care if you do that. Okay, I don't want you to do this and then they count it wrong. All right. And then you say, well, that guy in that video said we could write it like that. Check with your teacher first. I'm sure they won't mind. If they don't let you do that, then that just means they're mean. All right. All right, so now we got to do it for k equals 1. Okay, now for k equals 1. So see, I'm going to plug everything back into this thing, except instead of plugging 0 in for k, I'm plugging 1 in for k. So that's going to be 2, and then I'm doing it in abbreviated form. So that's 120 plus 360 times 1 over 4. All right, see how much space that saves? And so this is going to be 2. And then let's see, 120 plus 360, and then divide that by 4. That is 120. All right. Now remember here, you're doing 2 times cosine of 120 plus I sine 120. That's what this means. So this is going to be what? 2 times, and then the cosine of 120. Now look, I'm not going to sit here and go through every one of these, drawing the reference angles out and all that stuff. You should know how to do that already. All right, so we got to do the cosine of 120. What's the cosine of 120? Well, the reference angle is 60. Cosine of 60 is 1/2. 120 is in the second quadrant. Cosine's negative, so that's negative 1/2. Plus, and then we've got the sine of 120 plus I times the sine of 120. Well, the reference angle 60, sine of 60 is square root of 3 over 2. I'm in the second quadrant, that's positive, so that's square root of 3 over 2. And so that's negative 1 plus I square root of 3. And there's your solution for k equals 1. And then we have to do for k equals 2. So that's going to be 2. And then that's going to be 120 plus 360 times 2 over 4, which that's 2. And then let's see, what is that when we put that in our calculator? That's 210. All right. So that's going to be 2 times. Okay, so we've got 210, that's in the third quadrant. Let's see, what's 210 minus 180 is 30. So 30 is our reference angle. So the cosine of 30 is what? Square root of 3 over 2. 210 is in the third quadrant, so it's negative. And then I've got the sine of the reference angle. The sine of 30 is 1/2, right? Look, let me just draw this one out. It's bothering me in case you don't understand. Look, there's 210, right? There's 210. Here's my reference angle, 30 degrees, okay? I'm just doing all this in my head, all right? So what's the cosine of 30? Square root of 3 over 2. I'm in the third quadrant, so it's negative. See that? Then I've got to do plus I sine of 210. Well, what's the sine of 30? 1/2. I'm in the third quadrant, so it's negative. So minus 1/2 I. And so this is going to be negative square root of 3 minus I. And there's that one. All right, so that's all I'm doing, what I just drew there. All right, so then I've got K equals 3. So I've got 2, and that's going to be 120 plus 360 times 3 over 4 equals 2. And then let's see, what is that? That's 300 degrees. And so now we've got to do cosine 300 plus I sine 300. All right, see, I'm just abbreviating everything. Instead of writing it all out like this, I'm abbreviating it. All right, so 300 is in the fourth quadrant. What's the reference angle? 360 minus 300. So the reference angle is 60 degrees. So the cosine of 60 is 1/2. I'm in the fourth quadrant. Cosine is positive. And then I've got the sine of 300. Well, the reference angle is 60. The sine of 60 is square root of 3 over 2. I'm in the fourth quadrant. Sine is negative. And so that's going to be 1 minus I square root of 3. And that's your answer. And that's your 4/4 roots of that. All right? And that's what this nth root theorem does here. That's what it does. You find all nth roots of a complex number. And remember, it has to be in trigonometric form. Okay? All right, so now, this is the last example. This is solving an equation. We want to find all solutions. So we're going to find all 6th roots. Okay? So we've got x to the 6th is equal to 1. Let's see if we add the 1 to both sides. So what's x? It's the 6th root of this, right? And we want to find all 6th roots. Okay? So we need to find all 6th roots of 1. Of this number here, 1. Now remember, 1 is 1 plus 0i. We can write it in that form, a plus bi. Okay? Now, we've got to convert this to trigonometric form. So r is the square root of a squared plus b squared, which that's 1. Well, that's nice. We're going to have a 1 in front. Remember last time we had the 2 in front? This time we got a 1 in front. Now we need theta, don't we? So what's theta? Theta is b over a, right? Well, look, this right here is what's nice. Just graph it. Graph this thing, 1 plus 0i. So what happens when you do that? So a is 1, b is 0. So it's right there. You see that? So look at that. Theta is just 0 degrees. You see that? Theta is 0 degrees. I mean, there it is. I mean, if you would have plotted the point and it would have ended up here, it would have been 90 degrees. Look, if this was -1, just pretend like, use your imagination that this is -1, then you've got -1, 0, -1, 0, theta is what? 180. See there? Look, let's just suppose your complex number was I. Well, what's I? I is the same thing as 0 plus I. Plot that. 0, and then b is 1, so that's right there, right? 90 degrees. So those are easy when it's just like a number like 1 or -1, or if you just have a I or a negative I, or if you have 2I or -2I, just plot it. It's going to land on one of these axes right here, and there's your angle. There's nothing, you don't have to do anything else. Okay, so let's see. We know that n is what? 6, because we're finding all 6th roots, right? And this is for k equals 0, 1, 2, 3, 4, 5. Oh, there's a bunch of them there. And r is 1, and theta is 0. And then r to the 1/6, go ahead and calculate it, which that's easy. That's just 1. Okay, so this turns out to be a pretty easy problem here. So for k equals 0, and I'm not going to write the 1 in front, but let's use the abbreviated notation. So that's going to be what? That's going to be 0 plus 360 times 0 over 6, which that's going to be, whoop, why did I write theta? 0 degrees, right? And so then I've got to do cosine 0. And look, you know, this should be a 1 in front. I'm just, 1 times that is just the same thing, so you don't have to write the 1 in front. Okay, now I do cosine 0 plus I sine 0. So that's going to be cosine 0 is 1, sine of 0 is 0, and so that's just 1. There's your first solution. All right, now let's get the next one. So for k equal 1, this is going to be 0 degrees plus 360 times 1 over 6. And that's going to be, what is that? That is 60 degrees. And so cosine of 60 is 1/2 plus sine of 60. So that's square root of 3 over 2i. That's a 3. It's not a good 3, but it is a 3. And so that's your solution there. There's your next solution. Now for k equal 2, so I get 0 plus 360 times 2, and that is going to be, what is that, 120? And look, I'm not going to go through and, you know, do all this. I mean, it's -1/2 plus square root of 3 over 2 times I. There's your next solution. And then for k equals 3, I get 0 plus 360 times 3 over 6. And so that's going to be 180. And so, well, let's see, the cosine of 180 is -1. Sine of 180 is 0. And so that's just -1. And then for k equals 4, I get 0 plus 360 times 4 over 6. And so, once again, we're staying with the abbreviated notation, so that's 240. And so that's just going to be -1/2 minus square root of 3 over 2 times I. See, 240 is in the third quadrant, so you know sine and cosine, they're both negative. And then k equals 5. That's 0 plus 360 times 5 over 6. And so, once again, with the abbreviated notation, that's 300. And look, I mean, we did the 300 degrees up here, same thing. And so that's going to be 1/2 minus square root of 3 over 2 times I. And that's your answer there. Well, I sure hope this video helped. I know it was only 3 problems, but I mean, you know, 2 of the problems was just using that nth root theorem. You know, those big long problems like that. So, I mean, it's not bad. It's not bad. But the thing you've got to remember to do this section in a trig book and the section before this in a trig book, you've got to know how to convert from a+bi form to trigonometric form, and how to convert from trigonometric form back to the a+bi form. Now, if watching this video, you're sitting there thinking, well, I'm not quite sure on all this converting, go watch the video right before this one, because that's where we go over that stuff. Okay? That's where we go over it. I'm sorry I didn't go into more detail on it on this video, but you know, if you're doing this section in a trig class, your teacher's not going to go into a lot of depth on the converting either in this section, because it was covered in the last in the section previous. That's typically how it would be in trig books. They'll go over all the conversion stuff, and then they'll work these types of problems in the section after that. All right. So I hope the video helped. If you're taking trig, good luck in your class. Check out my other videos. Give me a like, share, and subscribe. And thanks for watching, and I will see you later.